The algorithm of division of a two-digit number by a one-digit number is the same as division of a four-digit number by a three-digit number. The second is just an extended version of the first. It's often referred to as the long division process. For example, we can look at this already solved problem. 7,882 divided by 14 equals 563. This means that 563 times 14 equals 7,882. Or that 7,882 can be separated into 14 groups of 563 each. We come to this answer by first finding the largest multiple of 100 for which the divisor times the multiple is less than the dividend and subtracting the product from the dividend. In this example, we know that 500 times 14 equals 7,000. So we subtract 7,000 from 7,882, which gives us the new dividend of 882. Now we find the largest multiple of 10 for which the divisor times that multiple is less than the dividend and subtract the product of the dividend. We know that 14 times 60 equals 840. So we subtract 840 from 882, which gives us 42. Now, using our new dividend, 42, we can find the maximum times that 14 can clearly go into 42 and subtract it from the dividend. 14 times 3 equals 42. And 42 minus 42 equals 0. So we have reached the end of the division. We can see that the sum of the multiples that were calculated in the previous steps can be added to the result in the quotient. So 500 plus 60 plus 3 equals 563, which was given in the previous as a quotient. Now let's consider another problem. 2,736 divided by 14 equals 195, remainder 6. In this example, we know that 14 does not fit evenly into 2,736 because it has a remainder of 6. Or, in other words, 14 would fit evenly into 2,736 195 times if 6 was subtracted from the dividend, demonstrated by 14 times 195 equals 2,736 minus 6, or 14 times 195 plus 6 equals 2,736. Equivocally, 14 times 195 plus 6 equals 2,736, which can be rewritten as 14 times 100 plus 90 plus 5 plus 6 equals 2,736. In other words, 1,400 plus 1,260 plus 70 plus 6 equals 2,736. We can see that the sum of the largest factor of 100, whose product with 14 is less than the dividend, plus the largest multiple of 10 for which 14 times that multiple is less than the new dividend, plus the largest multiple of 14 that is less than the new dividend, plus the remainder of a whole number that does not contain any whole copies of divisor, equals the dividend. Let's consider the two previous examples and look at the general process of long division. First, we ask, how many copies of the divisor times 10 to the n power are contained in the dividend, where n is maximal? We subtract this from the 10 from the dividend. For example, consider 5,508 divided by 33. We find that one copy of 33 times 10 to the second power fits in the dividend. We subtract this from it. It gives us 2,208. Second, we ask, how many copies of the divisor times 10 to the n minus 1 are in the new dividend? Subtract this from the dividend. We find that 6 copies of 33 times 10 to the first is found in the dividend. This is 1980. Subtract this and we get 228. Repeat step 2 until the ones place is reached. You then find how many whole copies of the divisor fit into the dividend. You subtract this from the dividend and are left with an integer, which does not contain any whole copies of the divisor. This becomes the remainder. Our dividend was 228, so we're dividing 33, finding 6 whole copies of 33 fit into the dividend. That is 198. Subtract this from 228 and it leaves you with 30. 30 becomes the remainder.